All right, folks, we are coming up on the end of our project walkthrough here. We're going to look at the normal approximation and z-scores requirement here. In this one, I have asked you to choose one of the 6 columns that most approximates the normal distributions and show that it is approximately normal. Then calculate the mean and standard deviation for the sample and write 3 questions that correspond with the probability that a value selected at random is below some boundary, above that boundary, and between 2 different boundaries. So let's take a look at that. First thing we want to do is figure out which of our data are approximately normal, because when we are using these area calculators, right, they are assuming that the data is normal. So we don't want to use it on data that is not at least approximately normal, or we're going to have a pretty big error between our percentages that we come up with and what our normal calculator comes up with. So for now, our test for normality is going to be pretty ad hoc. You're going to go ahead and create some histograms and just kind of look at it and get a sense of whether it's normal or not. We created histograms for the very first graph that we made. It was pretty simple. We're going to create a couple quick ones right now. I'm actually going to create one for every one of our data sets. So I'm just going to go into the histogram maker here. Boom. I'm not going to worry about titles or anything. This is just for my own evaluation, trying to understand and explore the data. And we're just going to try to figure out which one of these is going to give us the most normal set of data. All right, in other words, which one is most bell-shaped? So we've spit out a whole bunch of graphs here. Let's sort of get them all together on the screen so we can look at them, understand their distributions, and try to pick the best one for that phase of the project. All right, so here we have our 6 teams. If I were to sort of do a quick analysis here, we got a skewed right for the San Diego Gulls, a skewed left for the Ontario Reign. We got another right skew here for the Coachella Valley Firebirds. Our LA Kings is kind of a uniform distribution. San Jose Sharks looks like it could be bimodal with the 2 humps. And so it looks like Anaheim Ducks are going to be our most normally distributed data. So the Anaheim Ducks are what we're going to use to answer the questions, because that is going to give us the most accurate results when we're doing a normal distribution calculator to find those results. Okay, so that's what I'm asking you to do in that first part of the question, is just look at the distributions, figure out which one it is. In your presentation, you probably copy this graph, put it into your slide, and tell me, hey, I looked at all 6 distributions, Anaheim Ducks were the most normally distributed, so I chose to use that data. You could even put all 6 in your presentation and show me that the Anaheim Ducks were the most normally distributed amongst them, and then go ahead and go on with your analysis. So the analysis says, calculate the sample mean and standard deviation for this column. So now that we know that we are using the ducks, I'm going to have to get rid of some of these. Kind of clogging up my screen here. Oh, I don't know. Maybe we'll do it over here. So we'll look at our Anaheim Ducks. We want to look at mean and standard deviation. And so we're just going to say average. Our Anaheim Ducks is column A. We just want the average of the whole column, so I'm just going to say A colon A. And it looks like our average there is 30.5 shots on goal. Our standard deviation, STDEV, Now, I did ask you to do the sample standard deviation. So you have your choice here between STDEVP and STDEVS. Now, I believe that the default one is the sample, but just to be sure, I'm going to go ahead and pick the STDEV.S. And in reality, the difference between the sample and population on 200 samples is going to be super negligible, but you know, that's what we asked for, so we're going to go with that. Okay. I'll change the decimals to 2 decimal places each. And there's our mean and standard deviation for the Anaheim Ducks that we'll use to answer the questions that we need to use. Okay, how are we going to get those answers? Well, we are going to use this neat little tool over in GeoGebra. We also could do the tables that we used in class, or Google Sheets, the way that we did on another project where you had to calculate it. But I think in this case, the GeoGebra tool is probably going to be the nicer thing to do here, and it's certainly going to be faster and give us some nice little visualizations. So for our mean, we want to go ahead and copy the mean from over here. Oops. And bring it into our normal distribution tool. Once this applet has loaded, this is defaulting to the standard normal curve of 0, mean of 0, standard deviation of 1. We'll learn more about that later. And all right, it has finally loaded. And let's go ahead and bring in the standard deviation now. And so there we go. We've got our mean and standard deviation. Now I can ask the questions. Maybe I want to know what % of games have fewer than 35 shots on goal. I can select this right bracket and come in here and type 35. And you'll see that it is shaded to the left there. So this tells me that there are 79.4% of games where fewer than 35 shots on goal were taken. If I go the other direction for the right shaded questions, I could say that there are 20.57% of games that are more than 35 shots on goal. And I could do this bracket here and answer the question of how many games have between 25 and 35 shots on goal and get 64%. Now, the only caveat I have here is that when you are making this graph, I do want you to practice some good presentation skills and help the reader understand, or help the viewer of your presentation understand what's going on. So when you bring this into your presentation, we're going to go something like insert, I don't know, drawing's the way to do this. It doesn't have to be the way you do it, but it's built into the Google stuff you're doing already. And, you know, we can add some titles here, like shots less than 35, more than 25. Let's see if I can move that. All right, well, it's a little bit fiddly, but you can probably get it to work. And what was our total here? It was 64%. So then we can go ahead and say 64%. And then we have a nice graphic that we can put into our presentation. And we probably want to shrink that up a little bit. You can play around with that, make it look good, make it so that your audience can see what you're talking about, and bring those pictures into your presentation as well when you're answering those questions. All right, that's it.